Welcome to Chips of Math Physics. In today's video, we shall be looking at differential equation. Differential equation is always represented in the form of dy over dx. So let us take an example. Assuming that we are to differentiate this simple or ordinary differential equation, negative x divided by y, then exponential x squared. What are you supposed to do? I have got a trick that I want you to know. A lot of students suffer in terms of this ordinary differential equation simply because of the lack of basic algebra and maybe the basic knowledge of integration. So let me show you the simple way to handle this question. So we can say this can be the equation we are given is dy over dx, and this is equal to x negative x divided by y exponential x squared. So when you are given this type of equation, let me take a red color. What we are going to do is we simply need to multiply y on both sides and dx on both sides, because the idea is to isolate y differently. You can see in this form we are having x and y, so we can actually multiply this place by y and also dx. We can as well do the same, multiply by y and actually dx. If you observe what happened here, we are having dx and we're having dx, and we are having y and we have y. So if we get rid of that, our original equation now will become y dy. Of course, dy is still remain. It is equals to negative x. If you observe what has happened in this equation, it is actually interesting now because we have negative x, then we have exponential. Remember, we have exponential x squared, so it will become exponential negative x squared. At this point, we can see that we have the values of y in one side and the values of x in one side. So now we can actually integrate this. If you integrate, you simply have the integral of y dy is equals to the integral of negative x exponential negative x squared dx. Now, if you take the integral of this, you will simply have y squared divided by 2 plus some constant c1. Remember that this is a different variable, and now since it is independent on its own, so we have to take some constant. We don't actually know what a constant is, but we will find out what exactly is that constant. And then we say the integral of negative x exponential negative x squared. We might need to use u substitution, because if you observe in this, you will have a negative x, so there is a kind of 2 here, so we can actually have in the front here, and we can bring 2 here. If you don't know how to do this, you can watch my previous video on where I explain on what to do in u substitution, so that you will use u substitution to integrate this function negative x exponential negative x, so that we will have a negative, this will be half exponential negative x squared, and this also plus some constant too. Of course, we don't know what that constant is, so if we continue from here, we will simply try to bring these like terms together so that we will have y squared divided by 2, y squared divided by 2. Take this half to the other side to become negative a half exponential negative x squared, and this will be equals to CO2 minus C1. Of course, since we don't know what this is, we can as well write it as to be equals to C. So C2 minus C1 will simply be C, so that our answer will be y2 y squared by 2 minus a half exponential negative x squared is equals to some constant C. This is what we call the implicit. This is the solution to this question, but this solution is implicit, and most lecturers will require you to arrive at this implicit solution, assuming that you were given some point, maybe x is equals to 2 and y is equals to 1. So now if you are given some limit this way, you can go ahead and now evaluate the value of x when x is 2 and the value of y when y is 1. Then you will find the value of c. Otherwise, this solution is acceptable, and this is how we try to evaluate the use of differentiation, ordinary differential equation. In the next video, we shall be looking at how to reduce some equation to a kind of separable form and then try to solve it. Otherwise, see you in our next video.